Okay. Okay, dear students, today we have to do this experiment as written on the blackboard. Our object is to find out two acidic and two basic radical in a given mixture. Okay. So we have a mixture here. First we have to detect two acidic radicals. We have to do in sequence. That is, first we have to check out for the group. For that purpose, we have to take a small amount of mixture in a test tube. Then for acidic first group, as you know, the group reagent is dilute sulfuric acid. We have to add dilute sulfuric acid in this mixture. And observe the changes. As you can clearly see, there is brisk effervescence in the test tube. It means that the given radical is carbonate. Okay, now we have to convert the carbonate. In order to confirm carbonate, we have to do lime water test. In a test tube, first we have to take lime water. Then in another test tube, take the mixture and add dilute sulfuric acid to it. Effervescence starts. Now through a delivery tube, we have to pass the gas evolved through the lime water. So it's see, confirmatory test for carbonate. After adding dilute sulfuric acid to carbonate, carbon dioxide gas is released, which when passed through lime water turns it milky due to the formation of calcium carbonate. Radical in the given mixture was carbonate. Now we have to check out for the second radical. As two radicals can't belong to the same group, therefore we have to check out for the second group. In second acidic group, the group reagent is concentrated sulfuric acid. The first one was from first group, that was carbonate. Now for second group, we have to add concentrated sulfuric acid to the given mixture. You have to carefully add concentrated sulfuric acid and check out the reaction. You can see the fumes that are evolving out from the test tube. Fumes have a pungent smell. It means that it may be chloride that belongs to the second group. Now, in order to confirm the chloride, we have to do chromyl chloride test. In chromyl chloride test, we have to take water or NaOH in a test tube, and in another test tube, we have to take mixture along with solid potassium dichromate, and then we have to add concentrated sulfuric acid in the test tube containing mixture and solid potassium dichromate. You can clearly see that orange fumes are evolving from the test tube. Now, with the help of delivery tube, we have to pass this gas through water. The gas that is evolved here is chromyl chloride gas.
आप फिंगर हटाइए, नज़र नहीं आ रहा है। हीट करिए और हीट करिए। हाँ
The gas that is evolved here is chromyl fluoride gas, which when passed through water convert it into pale yellow. Now we have to add lead acetate and acetic acid in this water. Which result in the formation of this yellow precipitate. It confirms the presence of chloride in the given mixture, that is known as chromyl chloride test.
Radicals, we will go for two unknown basic radical, and we'll start with the group 0. Group 0 radical is ammonium radical, and we have taken the mixture in the test tube. And for preliminary test of ammonium, we need to add sodium hydroxide just to smell ammonia gas. So I'm adding sodium hydroxide into it. After adding sodium hydroxide, we need to warm it up and check the smell. And on smelling the test tube, there is no smell of ammonia. It means that the chances of finding ammonium radical into the mixture is not here. Therefore, we will proceed to group 2, that is cadmium. For cadmium, we need to proceed group 2. Okay. After group 0 radical, we are proceeding towards group 2, that is for cadmium. And for cadmium, group reagent is dilute HCl and H2S gas. So again, I am taking mixture into the test tube. I am adding dilute HCl into it. After adding dilute HCl, now we are adding, either we can take H2S gas or H2S water. I am adding H2S water. Now see, test tube, in test tube, solution is colorless. There is no formation of yellow precipitate, and this means that cadmium is not present into the mixture. If cadmium is present, it would turn into yellow colored precipitate. The test tube is showing no color, that's why it shows that cadmium is not present into the mixture. 0 and group 2 will move to group 3rd basic radical, and for group 3rd we will go for aluminium. Here is the clear solution of the mixture. See, the mixture is totally dissolved in the medium. And now we are adding into this that group reagent. The group reagent is ammonium chloride solid and ammonium hydroxide in excess. So this is ammonium chloride. I am adding ammonium chloride into it. First, ammonium chloride should be dissolved. See, it is dissolved ammonium chloride. Now into this, I am adding excess of ammonium hydroxide. Quantity of ammonium hydroxide should be such that the smell of ammonia should be coming out of the test tube. Now here, after adding ammonium hydroxide, we can easily see the appearance of gelatinous precipitate. This appearance of gelatinous precipitate is clear indication of aluminium radical. Okay, so this means the first radical in this mixture in basic group is aluminium. After aluminium, we are moving towards group 4th basic radical, and radicals included in group 4 is zinc, manganese, nickel and cobalt. Nickel and cobalt, we are not testing the mixture for nickel and cobalt because these radicals are colored. This mixture is colorless, that's why we will go for zinc and manganese. Okay, so here is the solution of mixture in the water and dilute HCl. We are adding group reagent for group 4. Group reagent for group 4 is ammonium chloride solid, ammonium hydroxide and H2S gas. So here I am adding ammonium chloride solid. First we need to dissolve ammonium chloride into the medium. Now add ammonium hydroxide, excess of ammonium hydroxide to turn the medium into basic. I am adding ammonium hydroxide into it. Now after adding ammonium chloride and ammonium hydroxide, we will add H2S gas or H2S water. So here H2S water. Now as we have seen that in this test tube the precipitate is buff colored precipitate. For zinc, precipitate should be white. For manganese, precipitate should be buff. It means that in this mixture, second basic radical is manganese. The first radical which we have confirmed is aluminium by the indication of gelatinous precipitate, and second radical in the mixture is, second basic radical in the mixture is manganese. The four radicals in the mixture is carbonate, chloride, aluminium and manganese. So this is the whole demonstration of all the four radicals.